Morning, folks. Welcome to the Podman Community Meeting. Today is Tuesday, August 5th, 2025. I'm not sure where in the heck this is coming from. So generally on this meeting, we meet on the first Tuesday of even-numbered months. We may make the meeting a little friendlier for our Asian folks in India, China, Australia at some point in time. We'll keep you posted on that. Topics are driven from prior meetings or requests sent to me or added to the agenda, which we have up on the Google chat if you want to see that. Today we're going to be taking notes via Gemini, and then if you have any questions or if you have links or anything that want to be added to those, please go ahead and put those within the HackMD agenda. And so we're always happy to do discussions, particularly for Podman, Build a Scopio, but any other related container projects. And there's the meeting notes there. So today we have 3 talks. We're going to have a talk about Orches from Andre Butia, and hopefully I didn't pronounce that too badly. And then Podman MCP Uses with Brian Smith. And then Nalan Dahiabe will be talking about reproducible container builds. And then at the end, we'll ask for any topics or any questions that you may have. So with all that, I'm going to stop sharing, and I will go ahead and turn it over to Andre.
All right, let me share my screen. All right, I think it worked. So, by the way, no one told me how much time do I have. I have a content for about 12 minutes. I hope it's fine.
Yeah, we have generally about 15 minutes, so it sounds very hot.
Awesome. So, yeah, I am here to talk about Orches, and I don't know how to pronounce it. I don't know why I name a project in such a way that I don't know how to pronounce it. So I call it Orches. I don't know, like the word orchestration. And yeah, I won't say I work for Red Hat, but this is my pet project. Doesn't actually have anything to do with my day job. Well, kinda. I don't know. I work on operating systems. So Orches. It's a simple GitOps tool for Podman and systemd. And the structure of this demo will be that first I will talk about the story why I made it, because I think it's pretty important to understand what problem I'm trying to solve. And then I will have a live demo that will hopefully go all right. So let's jump right into it. So at one point I got a server and I wanted to host applications on it, and that was my goal. I wanted to host stuff like Jellyfin, SyncFink, ForJo, the usual stuff that you host on your own infra if you want to, if you don't want to rely on cloud providers or third-party services. And of course, I wanted to use containers because what else would you use nowadays? But I had one thing that I really wanted to use in this new deployment, and that was GitOps. So in the case you don't know GitOps, GitOps is a way of managing your servers where you have just a repository of some declarative files, and whatever you want to change in your deployment, you just send a change or push a change to your repository, and then the server will just automatically apply the configuration in that repository and reconcile or basically update itself. So in this case, this is kind of Kubernetes-like syntax for containers. It's a bit simplified, so it fits on the screen. But yeah, this change is basically about updating SyncFink. SyncFink is just an application for syncing files between computers. And in this change, I am actually updating SyncFink from 1.29 to 1.30. And in a GitOps workflow, I just need to commit this change, push it somewhere, and then the server will just update the SyncFink container. So it will stop the old one, bring up a new one, and everything works. So this is what I really wanted, because we use, so in my day job, we use Terraform. We actually use Kubernetes. I will talk about it a bit on the next slide. And it's just magic. I don't like SSHing somewhere and running bash commands or Ansible. I would just like to work with a repository if possible. So I went the natural way and I deployed Kubernetes because yeah, Kubernetes has basically two projects with that are doing GitOps. It has Argo CD and Flux. I chose Argo CD because it has a nice UI, so I can actually visually see everything. And Argo CD, it's basically an operator running on Kubernetes, which does exactly what I described. So you point it at a Git repository, and Argo CD periodically checks for updates in that repository and applies the resources, applies all the Kubernetes files in the repository to your cluster, and it just makes it up to date with the remote repository. This is amazing. It works. But the issue is that now I have Kubernetes running at home. And I mean, Kubernetes, don't get me wrong, it's a great tool, but it's great for production-grade applications, large scale. But if I want to just run, one server, some containers, I don't know, maybe 20, 10 of them, like not too much, not too many. It's just an overkill, and like you need to make decisions regarding your deployments. It's just hard. And at one point, I just realized I miss Podman. I just like running containers using Podman. It's so simple. Just do Podman start, Podman run, and you have a container. What else I need? I don't need a whole Kubernetes thing to run 10 containers. So I looked over the internet. I found some projects that are trying to solve this issue. But like they were not very well documented, they were not very well maintained. So I did what we all do. I started my own, and yeah, I made Orches, which is a tool for managing Podman containers and system units on a single node. So it's not multi-node like Kubernetes. Everything runs on a single node. And it does exactly what I described earlier. So you point it at a Git repository, and it just periodically fetches, or searches for any updates there, and applies them to your system. And the core of it are, of course, the super amazing Podman system units, also called Quartlets. I think that the name is still alive. So that's it. So I can actually show you how the exact same thing that I described here works with Quartlets. Like this is actually a screenshot of a commit from my real Orches repository. So the same thing. So I'm updating syncthing. Actually, it's not even created by me. I am running a bot, Renovate, to update all of my containers. And so Orches, when it runs on your node, it just scans this repository periodically, and it just applies the new Quartlet when it finds a new one in the repository. So I think it will be better explained in a demo. So let's have some fun, and let's show you how it works. Yeah. So let me start. So Orches. It's just a small Go repository. It doesn't have too many lines of code. And for this, I will start with the rootless template, because Orches can support both rootful and rootless containers. I tried to run everything rootless. So let's start with this one. So Orches config rootless, and here are the steps needed to start with Orches. So firstly, two small steps to prepare. The first one is to enable lingering, because if you don't enable lingering, then all your resources will be killed after you log off your server. So we need to enable this. Oh, and by the way, I forgot to mention, what are we using? We are using, I hope it's big enough. I can maybe make it even slightly bigger. Yeah. So Orches is quite distribution independent. It basically needs two things. It needs systemd, which is everywhere, and Podman. So I tried Debian, worked wonderfully. Fedora and CentOS, of course, works wonderfully. And this one, I'm actually on most of my deployments, I run some kind of a Bootsy thing. So this thing is actually the stock Fedora Bootsy image, because it has Podman and systemd. So let me copy these commands. So enable lingering. We need some directories that Orches will use. and then I need to run this big ugly command. So let me very quickly explain what it does. So it's just Podman run with some extra privileges, because I will need to control systemd on the host from a container. So I will need to mount some systemd stuff into the container, and then some volume, some configuration, nothing interesting. This is the Orches upstream container that is maintained in this repository, and I'm calling the init operation on this repository itself. So this is actually this repository. And if I take a look here, it has readme, renovate file, nothing interesting, and then two files. The Orches container itself, which is basically the same thing as here, just defined in the quadlet. So Orches is actually self-managing itself, so you can update Orches by just updating its container file. And the other thing that we have here is just a simple web server, so Caddy, published on a port. We will see it later. So what this will do, it will initialize Orches, run it as a container, and one payload container will be there with just a Caddy container. So let's just run it and see if it works. For the reference, because pulling containers take a while, I pre-cached all the containers, or pre-pulled all the containers on this node, so we don't have to wait. And you can see that it was initialized, the Orches deployment, and we now have two containers running. And I can actually indeed see that there are two containers running. So there's Orches container, there is Caddy container. And let me just very quickly verify that it runs. So this is the IP address, I'm pretty sure, 243, yes, port 8080. And yes, Orches worked. And now we have running Orches deployment. And I can actually run podman exec system the Orches, which is the name of the Orches container, and I can ask it, hey, what's the status? And the status is, this is the remote, and we are pointing at this reference, which I can double check. Yeah, this is the latest commit, 2086, 2086. Great. Now what else I can do? I can actually use this template. So let me very quickly create a new repository, call it demo, choose the owner, that's me. Let's very quickly create it. And it should be done very quickly. And I can actually say, hey, Orches, now let's point to my repository. And now Orches is pointing at my repository. The deployment should be still running. Yes, it's still running. So now Orches will, every 2 minutes, it will pull from this repository and see if there are any changes. So let's make a change. Let's go to the Caddy container file, and let's just very quickly, I don't know, change a port. And now Orches will resync after like 2 minutes or something. We can actually make it a bit bigger, a bit faster. So I can just call Orches sync, and we'll sync the deployment. Let's refresh. And yeah, I'm unable to connect, but I can fix it by using a different port. So you can see Orches successfully synced my deployment was defined in my repository. The last thing that I want to show you is that I created a big repository with a bunch of examples. So I can just switch to it. Let's just switch to this one. It will be done in a minute. Yes, it's done. And this is why I needed to prefetch the containers, because there are like 8 of them running and it takes a while to pull them. And yeah, this repository, it contains like 8 services ready to go. So for example, on the port 8080, this repository that we are now following, it has the Forjo Git Porch. And yeah, this is the Forjo installation page. I can, for example, show you the Jellyfin, well, installation page. Everything needs to be installed because this is a brand new deployment. But yeah, everything seems to be running. So now we are following this example repository. And the last thing that we can do, by the way, I can show you that, yeah, we have a bunch of containers running on our machine right now. And the last thing Orches can do, it can do prune, which means that it will just remove everything. It takes a while because we need to stop all the containers. So give it a second. And yeah, nothing is running. So everything is cleaned up. All the container units are gone. I cannot access anything. And yeah, this is it. This is how we use Orches in like 5 minutes. So yeah, Orches, it's available on GitHub. I am using it on like 2, 3, 4, I don't know how many deployments currently I have. And it works quite wonderful. And together with Renovate, it allows me to pin the container versions and then update them using pull requests. I just need to merge. It works very wonderfully. The next thing that I want to work on when time allows is that I would like to implement support for systemd timers, because I think that using systemd timers for backups would be amazing. So, every night just make a copy of all the volumes and rsync them somewhere, something like it. I think that would be a fairly nice workflow. And yeah, github.com/orchesteam/orches, just go there, check it out, play with it. I think it's pretty awesome. That's it. Thank you.
All right, thanks, Andre. That was great. Any questions, comments? On.
First of all, Andre, thank you for coming in and showing us the demo. Quick question. So if I point it to a repo, and is there any way that I can say, like, okay, I want to use like these ABC containers, even though if it has like 10 different containers?
Sorry. Like, you have a repository with 10 containers?
Yeah, but I want to only to run like 3 containers out of that.
Oh, I see. So currently there is no way to do it, but there were some discussions in the upstream issues about this, because you are not the only one who wants that. And currently there are 2 proposed solutions. So we would like to merge to have this feature together with support for multiple servers being driven from one repository, because I think it makes sense so that you can point multiple servers at one repository and then have defined which containers are run on which machines. So this is something that is documented there, and people would love that. So it's not currently implemented, but there is a high demand for it, and I can absolutely see why this would be very useful.
Okay, thank you, Andre.
Sorry about that. Had somebody come to my door. Always perfect timing. Okay, any further questions for Andre? Otherwise, we'll move on to Brian. Great, Andre, thank you so much. It's really very interesting.
Yeah.
Brian Smith, you're going to be talking about Podman MCP Uses. Take it away.
Yeah. Hello, everyone. Yeah, my name is Brian Smith. Neil had just asked me to come on and present about some of the experimentation I've been doing, testing the model context protocol using containers and using Podman. If you're not familiar with the model context protocol, or MCP, I'll just cover kind of a brief overview. Basically, this is an open standard that was introduced at the end of 2024 by Anthropic. And what it allows large language model systems to do is basically interact with outside tools and data sources, which really greatly expands the potential use cases for these AI large language model systems. So if you think of a use case, if you asked one of these large language models, before this kind of technology was available, if you asked, what's the weather going to be in my location tomorrow, the large language model, didn't have that in its training data, so it didn't really have the ability to answer that kind of question, right? But if you are in this kind of MCP world, you could get a MCP server that is able to go out and get the weather forecast for you and provide that information back to the large language model. So those are the kind of use cases, where it basically enables a large language model to retrieve data and go out and make changes as well. So if you want more information on kind of how this works and what the standard defines and everything, there's the model context protocol.io website that has a lot more information. I also wanted to show, I found this list on GitHub. This is a list of, oh, this is the wrong, this one here, the list of MCP servers. So this is just kind of a list somebody put together, but it kind of shows that, you know, kind of the different areas that there are already MCP servers for, and they cover pretty much everything you can think of. So these are the different categories. And if you go look through this, there's literally hundreds of MCP servers out there, like I said, for pretty much any use case you can think of. And so I wanted a way to kind of experiment with this, and I wanted to use a container to do it. And so I found an MCP client that is a command line client. So this MCP CLI, this basically allows you to interact with you know, MCP servers from the command line. There are a lot of other MCP clients. This is another list of different clients that support MCP. So there's a lot of different options out there. I just happened to find this MCP CLI that seemed to work well in a container. And so that's what I've been kind of experimenting with. All right, so I put together a Git repo that has a container file and just some instructions on how I set this up. The container file is really pretty simple. It's built off CentOS Stream 9, installs some packages, installs that MCP CLI client that I was talking about before. And then I'm using Ollama, which is a open source inference tool to actually run the large language model within the container as well. And then once you've built the container, you basically just start up Ollama within the container. You pull down whatever model you'd like to use. In this example, I'm just using the Quinn 3 4 billion parameter model, but you can use, you know, any model of your choosing there. And then you basically just configure whatever MCP servers you'd like to experiment with. So most of the MCP servers you'll find will have this JSON syntax where you just basically copy and paste this into the server config.json file. And then you know, after you've done that, you can go ahead and run the MCP CLI chat within this container environment, and you know, start experimenting with these MCP servers. So let me show just a quick demo of what this, you know, kind of looks like, and, you know, just one example MCP server. So I'm here on a Fedora system. I built that container, you know, based on that container file that I referred to, and I've just started a shell in it. So what you need to do is run Ollama serve to start Ollama, and then I've already pulled down that Quinn model that I talked about. Again, you can use any model of your choosing. I just found that this Quinn model, this 4 billion parameter, is a very small model and runs very quickly, and so that's why I'm just experimenting with that. Once you've done that, like I said, you also want to define that server config with the list of MCP servers you'd like to experiment with. So in this example, I'm going to be showing this CLI MCP server, and what this does is allow the large language model to actually run commands in the environment. You can go through and configure this MCP server to, you know, restrict what commands it's allowed to run, what directories it's allowed to interact with. Just since I'm experimenting here, I have this opened up, so it's allowed to run any command, you know, any command flag, etc. All right, so once you've done that, you basically just start the MCP CLI client. So let me go ahead and run that. So I'm going to specify I'd like to use this CLI MCP server. That's what this is right here. And then I'm going to use Ollama, which is going to provide the LM inference that's running locally as well. Okay. So once I'm in here, I can you know, interact with this and ask questions, and it's going to be able to use that MCP server to run commands on the system. So for example, I could ask a question such as, how much memory does this system have? And using that MCP server, it's going to be able to run a command to go out and retrieve this information. This Quinn model, it's a thinking model, so you'll see it'll have the first part up here is it kind of thinking through what it needs to do. And then here you can see it actually runs the free command to go out and get that memory information for me. And then let me scroll down here. And okay, here down at the bottom, based on what it's been able to find, using that free command, it comes back and is able to correctly answer that the system has 64 gigs of memory. So just trying to show here that it was able to use that MCP server to run a command to get the information to come back to me with the answer. And just another example, I can ask the I can ask what are the processes running on this system. What are the processes running on the system? And again, it's going to think through what it needs to do, run a command, and then come back and tell me what processes it can see on the system. So I'll also ask, like, what is the uptime of this system? And again, it'll kind of think through, use the MCP server, run a command, and then answer the question. So anyways, that's just what I wanted to show. Basically, I just wanted to have a way to set up a quick environment to experiment with these different MCP servers within a container. So if any questions I can help out with on this?
Could you post some of the URLs onto Todd's document?
Yeah. I'll post a link to the repository where I have the container file and where you can learn more information on this.
Yeah, that'd be great. Thank you. Abhi.
Hi, Brian. Do you think if Podman can support running multiple MCP servers and giving a unified endpoint, would it be more helpful for management? Like if AI host can just connect to a unified API endpoint, a unified MCP endpoint, which exposes all the tools and resources for different MCP servers. So as a user, you don't have to manage multiple MCP servers with different endpoints.
Yeah, and there's a number of different tools out there. Let me go back over to this. So this is a list of MCP clients that I found. So there's a lot of different options out here for work, interacting with MCP clients, and a lot of these are a lot more advanced than that MCP command line interface that I was showing. So if you have more advanced use cases, there's a lot of different tools out there that can make some of this easier to work with.
Yeah, we are trying to look into this, like some of the features which we can add into Podman, so it can make MCP orchestration easier. But
right. Yeah, that makes sense. And there might be an opportunity too in the future to have like a MCP server that's focused on managing Podman containers, where the purpose of the MCP server is to be able to work with Podman containers, start, stop, Podman containers, that kind of stuff. That might be a potential MCP server that might be useful in the future.
Yeah, thanks.
Mm-hmm.
Any further questions for Brian? I'm not hearing anything. Brian, thanks so much. It's very
thanks,
interesting. And again, if you could shoot me a link to that GitHub project, I'll go ahead and include it in the notes. You can either do it in Gmail.
Yep, we'll do. Thanks, everyone.
Yep. Right. That we are going on to Nolan, talking about reproducible container builds.
Yep. Okay. Let me just start sharing my screen. Okay. That should be it.
Yep.
Right. There we go. All right. So for reproducible builds, the general idea is that we are attempting to make sure that the image we output is bit for bit the exact same if we give it the exact same inputs, even across multiple builds done at different times, hopefully even across different machines, although I haven't tested that one myself. And the big spoiler in this talk is actually given on the slide, which hopefully everyone can see. I can't see you, so if you can't, give a holler. So a lot of things get encoded into an image at build time. We create a history that includes the current date timestamp. Anything that's randomly generated during the build, anything that's created will have the current date stamp on as its mod time. If you're installing RPMs, RPM will store the install times in its database in multiple locations. DNF will do the same thing. It's a lot of things to keep track of, and what we ended up doing was just committing the image to a local directory, running the build twice, and then actually diffing everything in the image, including the config blob, the manifest, the individual layers themselves, the files in the layers, until we pinned down every single thing that was changing in the test inputs we had. This is not an exhaustive list you're seeing in front of you. There's actually more stuff in the demo that I'm going to show, but I found all of it yesterday afternoon, so we're going to be okay there. We've actually tried this before with the timestamp flag, and it was not what we needed. Basically, the big thing that shot it in the foot was that things that you ran during the build had no idea that this was going on, and they got in the way, or rather they didn't know to cooperate, and it didn't turn out the way we wanted. So coming in build 1.41, actually 1.41 came out already, but there's at least a couple of things I want to fix before the next dot release, and it'll be rolled into Podman 5.6, is we essentially piggyback on top of functionality that already exists, which is the reproduciblebuild.org source date epoch spec. In particular, RPM already knows about this, so it and DNF will do a lot of the heavy lifting for us during a package build. We also replace a lot of things that we would randomly generate, because why would we have a fixed value for them? Turns out, in this case, we do need to have a fixed value for them. And we went through this. It's an iterative process, but we got most of that stuff figured out in time for 1.41. In Docker build, they also support source date epoch, but you need to supply a particular flag to tell it to change the timestamps of things in the layers that you're creating. So we had to punt that one and make it a separate command line flag, which you can use in combination with source date epoch or not. I recommend you do, because most of the time it's what you want, but this is just a concession to compatibility with other workflows. The source date epoch is, let me back up just a second. The notion of it is a timestamp, wherein theoretically, it's the timestamp of the latest bit of input that was changed from the last time you did the build. So in the demonstration I'm about to show, and we might as well just jump straight to that, it's actually going to be the build date of the most recent build date of all of the RPM packages we're going to install. And as my demonstration, I'm going to actually use the build image that we use and distribute on Quay.io. And as you can see and get that in, thanks to Git diff colorizing the output, there's been some changes from the upstream one that we currently have to the version that I'm going to build. In particular, the first thing we do is we define source date epoch as a build arg. This has the side effect of exposing it as an environment variable to commands that we run during the build, because args are copied over into the environment, in particular so that DNF and RPM know that that's what's going on here. We also need to install SQLite 3, because we do still have to muck with the transaction database at the very end of the transaction to make sure that to update some things that DNF doesn't do for us here. And then I just added a couple of sanity checks in here in the middle so that everything looks the way we expect it to be, and that the source date epoch, which I have to pass from outside of the build, matches what the inside of the build thinks it should have been. Computing the source date epoch is, well, deciding what value to pass in is actually the most complicated thing once this feature lands. And I don't have a good plan for how to do this in production, because if this test fails, then the whole build fails, and you have to start over with the value that it printed out, which is not very easy to script. We'll figure that out. So for a demonstration, we'll just start with, as a point of reference, this is a copy of the image in a directory that I built earlier today. Timestamps are, about an hour and a half ago. And I will build the exact same image now. You can see that this is just a copy of build that I have in my home directory, multiple layers, telling it to skip the cache, because we don't want to be depending on build cache for this one, because we actually want to build it fresh. We'll pass the source date epoch. And that date is when the most recent package that's going to be pulled in for this was built, which is 4 days ago. So let's see. We also pass source date epoch in. We use reproduct timestamp, and I'm going to commit it to a new directory that didn't just exist. And we're at the mercy of the speed of my network connection here. At this point, while it's going, I could entertain questions if anybody has one. I've been going kind of a little fast. I'm sorry about that. Did I accidentally mute my speaker?
Nope, I request for questions, so you're good.
Okay. What we're seeing here is DNF is just installing a bunch of packages. In particular, it's going to take notice of the source date epoch flag, and RPM is going to do us a favor and make sure that none of the timestamps of things it's creating are later than that. It's also going to record the date the source date epoch value as the install date in its RPM database, so the RPM database will not be different. We did have to mess with its transaction database because the transaction dates aren't changed for us, but the TNF maintainers were very kind in suggesting the command line that we would have to use to do it. So, I've just built this directory, and if everything works correctly, this manifest will be exactly the same as the one that I built earlier. Hey, they are the same. So if I push this, even with a new tag, there will be no content actually updated to the new registry. Someone who pulls from an updated tag will also not have to download a new version of an image or anything. Bandwidth is saved, children laughing and singing. Any questions? Okay, I'm going to take it as a no, and I'm going to remind that most of this is landed in build at 1.41.0 and will be in Podman 5.6.
Great. Great demo, Nolan. I think once people start using this, they're going to be very happy with it.
Oh, I hope so.
Yeah. Even the children clapping. Like, so we'll see. Last chance. Any questions for Nolan? Right. That is the last demo that we had scheduled today. So I will also open it up for any questions at all. And while you're considering that, I'll just run over when our next meetings are coming up. Our next community meeting will be on October 7th. So it's about as far apart as they can get. And that will be at 11 a.m. Eastern time. And our next fall meeting, which is usually talking rather than demos, talking about design kind of things or issues with Podman or the other container tools, is on September 2nd, which is the Tuesday after Labor Day this year, which is also very early. And that's coming up right around the corner next month. So last call for questions, comments, or topics for the next meeting that people would like to see. Right. With that, I'll stop the recording.